this ventilation industry. So hope I'm audible to all. Right now, can we start?
Yeah, yes, please share your screen.
So my screen is visible right now.
Yeah.
So here are some basic blade designs are there for the fans. Before proceeding for the application wise, I will just give some little information about the blades. There are multiple kind of blades. There is centrifugal blades, axial blade, and mixed flow blade. So which is for being used for the different of kind of fans and different kind of application. So first we'll cover the centrifugal fan. In centrifugal fan, there is two type of blades. One is a DIDW fans and other is a SISW fan. And in DIDW, there is again forward curve, backward curve, and aerofoil blades over there. So here the things is, this is again forward curve, backward curve, and aerofoil curve is being used for the different of application, which we'll discuss in the later slides. And at the same time, there is a DIDW, double inlet, double width, and the single inlet, single width, that is also having the certain application wise construction, which is being used for the different of application, and we'll discuss in the later slides. So further to that, there is an axial fan, and in axial fan also there is a multiple kind of blade configuration, multiple times of construction of the fan. There is a direct driven of tube axial fan, then belt driven tube axial fan, then bifurcated tube axial fan, and vane axial fan. And further to that, we have upgraded one more model, that is a mixed flow fan, which is the combination of the axial as well as the centrifugal, and that too also having certain purpose, certain application. On that basis, we are using these kind of fans. And in axial fan also one more segment, that is a propeller fan. So mainly there is a two segment is there. You can see, say one is a centrifugal fan and second one is the axial fan. So basically centrifugal and axial fan major difference is axial fan is known for the higher volume, whereas the centrifugal fan is being used for the higher volume as well as for the higher static pressure. So whenever our application is like for higher volume, we'll directly should go with the axial fan. At the same time, when your static is also high along with your CFM, then we should select for the centrifugal fan. So so in this case, we are having different application in the ventilation industry. Which is we are going to brief you. Yeah. So in ventilation, there is a AHU application, air handling unit, then general ventilation, then kitchen ventilation, staircase pressurization, basement ventilation, and factory and warehouses ventilation, which we are going to cover, and we are going to brief how to select the fan for different of these kind of application. So first we'll cover the AHU application. AHU, air handling unit, everyone is known. It is for the air circulation, for the better comfort cooling, and for air handling unit we are using the centrifugal fan. So here you can see the centrifugal fan also having the ADA fan, as I told you, aerofoil curve, backward curve, and forward curve. So basically aerofoil and backward curve is almost having the same configuration. The things between that, aerofoil is having some better curvature over the blade, and which gives the better efficiency than the backward curve fan. And forward, there is a difference between forward curve and backward curve fan. Forward curve is made up of GI material, and whereas the backward curve is made up with the MS material. Whereas backward curve is being used where static pressure is more than 50 mm, because due to high strength it can handle the more static pressure. So always when our static pressure is more than 50 mm, we should preferably go with the either backward curve fan, either aerofoil curve. That is again depend upon your efficiency requirement. Whereas the forward curve, which can be generate less static pressure, which can say up to 50 mm static, and for the lesser efficiency we are using the forward curve fan. The backward curve fan, as I told, it is very similar to the aerofoil curve. The things is it is having little bit lesser efficiency than the aerofoil curve, and it's being used for the all the applications, similar application where we are using aerofoil curve impeller. Further to that, this forward curve fan, which wherever our static pressure is less than 50 mm static, we are supposed to go with the forward curve fan for the all kind of EHU application. Then further to that, plug fan, which is very known in the ventilation segment for the air handling unit. This is again having the backward curve, and it is comes with the direct driven, which is reduce the belt losses, because when you are going for the centrifugal fan, they're basically used with the belt driven unit. And whereas the plug fan, it is being used with the direct driven, there is no belt loss, so it is having better efficiency than the centrifugal fan. So this fan is available with any sort of motor like I2, I3, I4 and I5. So as per your requirement, as per your power saving requirement, you can proceed with the different of motor configuration. Further to that, what we have recently introduced for the EHU application, that is the mixed flow axial fan. This is basically the combination of the axial as well as the centrifugal impeller. So this is being used for the EHU application for any kind of exhaust and supply application, and it is available with the belt driven and direct driven in both the configuration. Basically, why we are using belt driven and direct driven, when some chemical part or some application where motors cannot be in airflow path, so then we are going with the belt driven kind of setup for this mixed flow fan. So there is the major difference, because as you are aware that in kitchen exhaust fan, your temperature is more than 80 degree, where very few motor manufacturers are making the motor with 80 degree continuous operation. At that point of time, we are preferably going with the bifurcation mode, where motor will be bifurcated from the airflow paths to safeguard the motor, because the motor is the weakest part of the fan. Then further to that, will come for the general ventilation. General ventilation covers for the comfort cooling for the fresh air and exhaust air application, where CFM is not very high, but yes, obviously for the office application, for toilet and normal kitchen ventilation, there also fresh air and as well as exhaust air fan will be required. So for that reason, we are having fan with the mixed flow kind of fan, then backward curve fan, then ceiling mount arrangement kind of fan. So here also it is basically known as a domestic fan, where capacity is less than 5000 CFM or 6000 CFM. Here again, your static pressure comes from the 10 mm static to up to 50 mm static, where again you can use forward curve fan as well as mixed flow fan, and our inline fan, which is available with the both the configuration forward curve, mixed flow fan, and as well as with the backward curve configuration. Then further into domestic segment, it will become for the propeller fan. Propeller fan is being used for the normal toilet, for offices exhaust, and for fresh air application, where we are having multiple product range which can be catered for your CFM. You can say from range 100 mm static to up to 5 to 7000 CFM. So which can be used for the any kind of exhaust and as well as for the fresh air application. Then inline fan, it is again available with the belt driven and direct driven. So that is again depend upon your capacity. When your lesser capacity, if you are having with the lesser static pressure, then you can always select direct driven. And when your capacity is increasing along with the static pressure, we are having the fans which can cater up to 6000 CFM, 7000 CFM with 50 to 80 mm static, with the belt driven as well as the direct driven setup. So basically the wall mounted fan and duct inline fan, we can use a wall mounted fan directly to the for exhaust and supply, which can be fixed into the wall, and it can be propeller fan can be used for the small or small open toilet area, wherever building, if you are having like you don't have much space to put the fan. So there always we should go with the propeller fan. And inline fan, where when you are having the huge bigger room and your air volume is huge, so then you can go with the inline fan. So in our product range, DWA, APM, APL series is available in the propeller fan category. At the same time, in inline fan, we are having TSK series fan, MTD silent series fan, CCD series fan, CSD series fan, and CFT series fan, which is available with the belt driven as well as the direct driven application. Then we'll further in ventilation segment, we'll come to the kitchen exhaust ventilation. So nowadays kitchen ventilation having a like every hotels, every sometimes small like cafeteria, so offices building, almost everyone is having the kitchen exhaust application kind of setup. So basically we have to select the right fan, and nowadays energy efficient has become a bigger challenge. Everyone is thinking about the energy efficient. So here we are having kitchen ventilation fan, where it is there with the direct driven as well as the belt driven arrangement. So here you can see there will be always scrubber will be there, your duct setup will be there. So at the different CFM, and according to your space availability, we are having different kind of fan. So mainly with SISW fan, which is very famous for the kitchen ventilation, and it is available with the belt driven as well as the direct driven arrangement. Mainly the main key feature of the kitchen SISW fan, and what we have to think before proceeding for the kitchen ventilation, we have to safeguard our motor, because as everyone is aware that key oily and greasy particle always will be there in the airflow path, as well as your air temperature always will be more than 60 to 80 degree temperature. So always we are aware that our motor is the weakest part of the fan, which has to be sustained for such a high temperature for the continuous operation, because many of the hotels are running 24/7, and at the peak time like dinner time and breakfast time, your capacity is more, so that time always air temperature will be more. So here Kruger is always recommending to go with the fan which having the such arrangement where motor will be outside from the airflow path. So for that, SISW fan is the one of the best suitable fan, which can cater static pressure up to 200 mm static pressure, as well as it can cater CFM range up to 50,000 to 80,000 CFM, and it is available with the both kind of both feature, direct driven as well as the belt driven arrangement. Basically direct driven and belt driven arrangement, when we are choosing, it is depend upon the your fan RPM. When your fan RPM is very equivalent to the your motor RPM, then, and if you're not using VFD, at that point of time you can directly go with the belt driven, because you are not using any VFD, and there is a huge difference between the your fan RPM and motor RPM. When at the same time, when you are using VFD and you are looking for some energy saving, always preferably we should go with the direct driven arrangement with the VFD and with the high grade of motor like i3, i4, i5 PM motor. At the same time, when some area which is very compact and there is no space to install the fan at terrace, or there is no location, like you are having very compact location and you want less dB fan, so always we should prefer to go with the cabinet fan. Cabinet is nothing but just an enclosure which will be having the lesser sound reduction. So in that case, there is a fan available with the DIDW also, and motor will be outside from airflow path. In that case, what you can see the arrangement over there in slides. Here we have kept the motor outside from airflow path, and it will be very compact into the design, since it is a DIDW fan and it will be both side suction. For that reason, fan size basically it will come down compared to the SISW fan. Similar to that, we are having one more smoke spill cabinet fan, which is being used for the kitchen ventilation as well as for the any high temperature. In this case, in certain cases, what will be happen? We are having separate cabinet for the inside the cabinet. One separate cabinet will be there for the motor, which will bifurcate the motor from the airflow path. So here again, if you are having the size height restriction, or you are not having the proper space to install, then you preferably we should go with the DIDW fan with the in such arrangement that motor will be outside from the airflow path. In the same ventilation segment, further to that, we will come for the staircase and lift well pressurization. Whenever we are going for the basement ventilation, there is always some or any mall, any commercial building, suppose some fire happens. So always preferably people will go with the staircase, they will avoid the lift, since there is high chance that fire is happened near to the lift or somewhere. So their lift well pressurization fan, there is also having the different of fans and different of height of the building. According to that, we have to select the fan. That is again backward curve, forward curve. That is will be basically defined as per your air volume, as per your static pressure. So here again we are recommending for the pressurization fan when it is doors is always, you are knowing that it is designed, it opens inwards into the system. So by that time we are using the pressurization fan, and it will actually allow you to easy opening of the door, and it will bifurcate the fume from the staircase so that people can easily escape. So in this case also we are having direct driven fan, belt driven fan, and the DIDW fan and SHW fan as per your application. So here, suppose if you are going with your static pressure is quite high, then you can go with the backward curve fan, belt driven, as well as the direct driven arrangement with the DIDW application. But at the same time, suppose if you are having something fire kind of application, then you have to go with preferably with SHW fan, where motor will be outside from airflow path. Further, you can see this slides where SHW fan can also will be used for the staircase pressurization, where you want motor has to be outside from the airflow path. At the same time, we are having fan, you can proceed with the direct driven axial fan, where your motor will be always class F, since you are pumping the air into the system. So here basically class H motor, most of the time it is not required. And we also recommend for the pressurization application, do not use class H motor, since there is a high chance that again which fume is coming from your staircase, that can be again come to the motor path. And if motor is class F, then obviously it will burn the motor and your fan will stop. So always we are recommending to go with the class F motor, because you are always pumping the air inside the system. Further to that, the ventilation, that flame proof and flame proof atmosphere. So there are multiple guidelines has been given for the explosive environment. For the they had given some classification from different body. They have asked to maintain the fan which has to be ATEX certified. ATEX is the body which will certify that fan is completely flame proof or spark resistance type. So here EMCA has given, basically EMCA has given a guideline. EMCA, probably everyone is aware that the body which will certify the fan, whatever air we are claiming, suppose some fan we are claiming this fan can is designed for 50,000 CFM, 60,000 CFM. So they will take the fan into their lab and they will certify that this fan can deliver this much CFM and static pressure. They will check it and verify, and they will give the certificate for the every fan manufacturer. It is very mandatory. At the same time, ATEX is again a third party body which will certify the fan. This can be used for the flame proof application. So basically EMCA has given three guidelines: EMCA A, EMCA B, and EMCA C. See, EMCA A is the most hazardous kind of construction, where it says that your complete fan has to be made up of the non-ferrous, and your motor has to be airflow path. Non-ferrous matter, it can be complete made up of aluminum, it can be made up of complete SS fan. And basically the reason behind that, whatever your rotating part and stationary part is there, has to be, if some by any chance came into the contact, so spark by that fan, spark should not be generated. So at that moment, type A says that the complete fan has to be non-ferrous and your motor should be suitable for group 2C gas, where it's cover the hydrogen gas also, which is the most flammable gas. Then type B says that suppose if you are having the fan, so there is out of rotatory and stationary part, out of one part should be non-ferrous between the rotatory and stationary part. Either it can be impeller, either it can be inlet cone. In MCA type C says that between the rotatory and stationary part, there is a non-ferrous material. Like in between the impeller and inlet cone, you can put the brass ring. So by that construction, you can make your fan like a flame proof, complete flame proof. So this is the major 3 guideline which we have to follow when we are going for any chemical exhaust, when we are going for where application is something spark can be generated. To basically our purpose is to avoid the spark over there. In multiple cases, we are seeing that at the same time BOQ called for the spark resistance type, at the same time it will ask for the smoke exhaust. So I'll just want to clear it out. Smoke fan cannot be used for the spark ventilation, and the spark resistant fan cannot be used for the smoke ventilation, because both the motor feature are different. For the smoke exhaust fan, motor feature is made for 250 degrees centigrade for 2 hours, which can be used only for the emergency and fire application. Whereas the spark resistance kind of motor made for 50-degree temperature just to avoid the spark, because if you see the frame size of the motor, it will be little bit bigger than the normal motor, since what the rotatory part inside the motor, they are keeping little distance. They are making motors in such a manner that rotatory part should not be in contact with somewhere into the stationary part. So always we have to be very cautious while selecting the fan for the spark resistance type as well as for the fireproof. So both are the very different concept. So here again we are having fan which is having with the flame proof motor. It is available with the inline fan. It is available with the propeller fan as well as the bifurcated tube axle fan. In bifurcated, our main purpose is motor we are bifurcating from the airflow path. In APN series fan, that is propeller fan, where we are putting the brass ring, either pagasse impeller and brass ring. Mainly there is no purpose, just we have to segregate the rotating and stationary part. Should not have the any contact, or if being in contact also, one part will be non-ferrous. For that reason, there will be no spark will be generated. At the same time, MTD-EX series fan, which is catering for the battery room and such a normal hazardous application, which is having group 2C gas motor as well as the impeller combination of the GSS as well as the plastic impeller. So further to that, suppose your CFM is very high, so we are having CFB series fan, which is again having the brass ring between the impeller as well as the inlet cone. So this is SISW into the construction, and we are using the group 2C gas or group 2B gas motor, which will allow us to make this fan construction in a spark resistance kind of. So further to that, in ventilation segment, it's a very general concept of the basement ventilation. So basement ventilation is the very crucial part for the any residential building, any commercial building, where we have to put the right fan at right place to get all the smoke outside for the comfort ventilation, as well as whoever is there in the parking area, they can walk comfortably out from the fire location. So for that location, basically for the basement ventilation, we are using a software called the CFD. So CFD is the basically purpose. It's a computational fluid dynamics, where we are calculating how much the CFM is required for the complete basement to get it exhaust, and how many fresh air CFM will be required to make the comfort cooling inside the basement. So in this case, designer wants some kind of data to make the CFD analysis. Basically, CFD analysis, it is to assess the performance of the ventilation system in case of normal as well as the fire mode. And in CFD analysis, we are having the identification of the area of the bulk airflow, short cycling of the fresh air, and stagnant areas. And in CFD analysis, we are doing the accurate positioning of the jet fan. Accurate positioning means jet fan is always works on the pull and push system actually. So it will wherever fire happened, for that particular location, jet fan will be switched on by the signal will be gone through the CO sensor to the panel, and that particular location jet fan will be switched on. So basically, for the doing the CFD analysis, some basic requirement is there, some architectural information will be there. What is the basement size? What is the plane view and sectional view of the site? What is the height of the basement? Where is beam is there? So and where is the parking area, and what is the capacity of the parking area? This basic requirement is basic data is required for the CFD analysis. And for that, further to that, we are putting all the data in the CFD software, and we will come to know the basically how much number of jet fan is required, and where we have to put, and in which direction we have to put the jet fan. And along with jet fan, we will come to know the how many CO sensor will be required, because CO sensor is going to play the vital role for the basement ventilation. So there are two type of ventilation system for the basement ventilation also. There is a ducted ventilation system and ductless ventilation system. So nowadays ductless ventilation system is the very famous. So we are going to brief on the ductless ventilation system. So there is the working principle of the basement ventilation system. One is the normal mode and other is the fire mode. So basically this will be decided by the CO sensor. So anything above 25 ppm is it's not okay for the human body. So there will be CO sensor which will detect the CO level in the basement. So it will give the signal to the panel, and on that basis panel will start running at low speed and high speed, because jet fan always comes with the two speed. One is the low speed and high speed. So whenever your CO ppm level will be below 25, nearby to the ppm 25 ppm, that fan will start running at low speed, and it will be give the signal. CO sensor will give the signal to the PLC panel, and PLC panel will give the signal to the nearest jet fan, which will evacuate the carbon gases nearby, whatever hazardous gases will be there. It will be pushed towards the next jet fan, as well as it will be pushed towards the nearest exhaust fan. So that is the basically for the normal mode. Then it comes for the fire mode. Fire mode, it will when some fire happen over there, when your ppm level is increased more than 25 ppm, and PLC panel will sense. There is logic also for the temperature sensor also there. When temperature also increased, then CO sensor and temperature sensor will give the signal to the starter panel, and starter panel will give the signal to the jet fan, and at that case jet fan start running at a high speed, and you can say it is a emergency mode. So basically in that case, what will be happen at emergency mode, all the fans, whereas axial fan as well as jet fan, all the fans will start at the high RPM, high speed, and it will try to evacuate the whatever the smokes or fume are there in the basement. So there also we can use the cabinet fan as well as axial fan, and the mainly use of the jet fan. So it is at the both case, at the fire mode as well as the smoke condition, like you can say the fire mode. So we are having their tube axial fan, and further to that we are having vane axial fan. So again, tube axial fan, there is the difference between the tube axial fan and vane axial fan. It is both used for the same purpose. Only the efficiency of the fan will be little bit higher side in the vane axial fan. So that is the major feature of the vane axial fan, which comes with the additional pod, and efficiency of the fan will be more, and in less BKW, it will consume less BKW, and noise of the fan will be very less. Then jet fan, they're cylindrical. There is two kind of jet fan. One is cylindrical kind of jet fan, which is known as a axial jet fan, as well as other kind of jet fan which is having the centrifugal jet fan. So here axial and centrifugal jet fan, both having the same purpose to evacuate the push and pull the air from one location to other location, and it will be reached to the nearest exhaust source of the axial fan as well as cabinet fan, whatever fan you have installed over there. So here you can see the feature wise. If you see in axial fan, there is a sound attenuator, whereas in a centrifugal fan there is no sound attenuator, since it will work on the concept of the centrifugal backward curve impeller, whereas the axial jet fan works on the concept of the axial jet fan. So axial kind of application. Here the main feature of this centrifugal jet fan, suppose if you are using axial jet fan, where attenuator will having certain acoustic property, and suppose today you are getting 80 dBA, so you will not get, after 5 years you will not get the same 80 dBA, because the dust and moisture particles will accumulate into the attenuator, and acoustic property of attenuator will be goes off. Whereas in centrifugal fan, there is no such concept. This fan is running with the 725, which is very quite low RPM, and highest RPM for this centrifugal jet fan is a 1450. And compared to, in terms of the coverage area, which is very most important for the basement ventilation, centrifugal jet fan is having more coverage area, whereas in compared to the axial jet fan. When you are going for any CFD analysis to arrive the quantity of jet fan, always your centrifugal jet fan is having lesser number of fans compared to the axial jet fan. So commercially, if you see, then your installation cost, your cable cost, your cable tray cost, so all costing per point of view, again it will become down, and it will become more effective than the axial jet fan. But the purpose is the same for the basement ventilation purpose. So here you can see the site photograph which is installed, and the other feature you can see, this is height wise, it is very less. You can see the throw side of this jet fan, which will come below the beam, which is only 120 mm, whereas in your axial jet fan, complete, suppose if you are using 355 jet fan, then complete 355 jet shape of the size will come below the beam. But here in this case, you see only throw side, which is only 120 mm in size, it will come below the beam. So if you are having the more space for the parking, and the better space, and look wise also, its aesthetic look of the fan is very good, you can see. Then further to that, in ventilation segment, will come for the factory and warehouse ventilation, where again it is required for the worker for the comfort cooling, where to maintain the temperature and humidity inside the factory premises. So here again we are having the propeller fan, as well as axial fan also can be used, inline fan also can be used. Here we are having one very good fan, which is having almost 40,000 cmh capacity with single phase. So it is very compact into the design. If you see in terms of the power consumption for the 40,000 CFM, only 1.1 kilowatt motor with single phase, it is required for the comfort cooling for the any warehouses or any factory premises. So this is the installation photograph for the location. Then you can see the HVLS fan. So in all the like factory location or any working place, so any workspace, you can see the HVLS fan nowadays very famous in the market. So this is again for the comfort cooling, and it can be used for the railway platform, for mall, cafeteria, any distribution center, or any gymnasium and all. So this is available up to 7-meter dia in the market. Then further to that, for the factory ventilation, the roof extractor fan. So roof extractor fan is having a different of you can say the feature. One is with the axial fan as well as with the centrifugal fan feature. So here you can see this is the axial fan, which can cater 1,50,000 cmh, And basically in this case, factory ventilation static pressure is very less, so we can proceed with the Excel kind of setup for the roof extractor fan. Whereas when your static is increasing for smoke spill application, then in that case we are having centrifugal smoke spill roof extractor fan, as well as belt driven kind of arrangement for the roof exhaust. This fan is very famous in the European market nowadays for the kitchen ventilation. This is having the special feature where motor will be outside from the airflow path. So in application wise, you can see nowadays roof extractor fan also can be used for the kitchen ventilation as well as for the smoke exhaust, which in earlier days only Excel fan was available in the market. So this is again, we are having the other segment also in the roof extractor fan. Further to that, Ferrari fan, which is our again part of the Kruger Ferrari fan, which is being used for the industrial application, for the air conditioning, general ventilation, local ventilation, for process industry, and in process air technology for the cleaning, conveying, drying, and safety airs, which is having, you can see here, it can deliver the air up to 30,000 cmh, and it can cater the static pressure up to 20,000 Pascal. So this is basically being used for the glass industry, any oil and gas industry, where high static and high air volume is required. So this is again, fans are available with the belt driven as well as the direct driven arrangement. So this is for the mainly being used for the industrial purpose. Then KRA rectangular attenuator, which is being provided for the any sort of application where sound attenuation is required for the system, like any buildings are there, any metro tunnels are there. So in those kind of, sometimes it is a sound dB requirement is a very mandatory. So that case you can use the KRA attenuator, which is having the sound reduction up to 20 dBA as per your requirement, and it is available with the different sizes as per your lengthwise and widthwise. It can be modified as per your requirement. So this is again tested for the fire rating also, as well as it is tested as accordance of ISO 7235, which will prove that whatever dB we are claiming, it will be completely achieved by this kind of sound attenuator. So this is all for the ventilation segment. So we will go for the 5-minute quick query. After that, I will also try to brief about the system effect, which is rather than selecting the fan, it is very important to know the system effect. What is the system effect in the ventilation segment to deliver the proper air and to get the better energy saving, just to take the consideration of the system effect. So in fan segment, if you have any query, we can proceed for the query first.
Thank you, Tarunji. It was a grateful session with you. Tarunji, there is one query. What is the full form of PAGAS?
It's a Pagas impeller. It's a non-ferrous metal, which is being used for the spark resistance. It's kind of material it is. Like aluminum impeller is there, Pagas impeller is there. So Pagas is the kind of non-ferrous metal which is being used for the where like spark resistance kind of something arrangement is required. So as I told that AMCA has given 3 guidelines where rotatory and stationary part, out of that one non-ferrous metal should be there. So metal to metal contact will be avoided and spark will be avoided over there.
If anyone has queries, then ask directly to the Tarunji. Another question is that, sir, what is the EC fan and EC plus fan? How they are consuming less power as compared to DIDW fans with induction motor?
See, EC fan, it's a very good concept came into the market, and it is for the energy saving point of view. Basically, EC and EC plus fan, you can say EC fan, it's a complete BLDC motor which is being used, and it is not like it is much power saving than the DIDW fan. It is again depend upon your CFM and static pressure, whereas an EC if you do the comparison between the EC and DIDW, first we have to see the what is the CFM and what is the static pressure, and we have to see the complete overall system effect also. When DIDW fan you are using, that time you have to use only single fan. When you are going with the EC fan or EC plus fan, you have to go with the multiple fan over there. So what is happening that your AMCA is given, which I'm going to explain into system effect also. When you are going for the AMCA guideline, they have given certain guideline for the installation also for the fan. So in that case, what is happening, whenever EC fan basically coming for the retrofit job also nowadays. So what is happening, whenever DIDW fan is installed, they will remove the DIDW fan and they will put the EC fan and with the multiple series of fan. So in that case, also having system effect also is coming into the picture. Over the period of time, what will be happening, as per AMCA guideline, always there should be minimal gap of minimum 2 times of the fan dia gap should be available in the system. So yes, EC fan, because you are dividing the CFM into multiple fans, and you are using only how many fans it is required at the moment. So you are calculating the power consumption for those particular fan only. But if you will go with the DIDW fan with the PM motor, with the VFD drive and the temperature sensor, if you equip the DIDW fan with all those equipment, you will get somewhere lesser, somewhere near to the same EC fan energy saving only. And EC fan, EC plus fan, I'll try to brief. EC plus fan, it is nothing what I have explained, the MXC series fan, that mixed flow fan with the VFD. If you see the EC plus fan, it is always come with the VFD drive. So there is nothing, speed is regulating on behalf of your actual requirement. So that is the concept of the EC plus fan.
Yes. Okay. I think Vivek ji, you got your answer?
Right, sir.
Okay. Then another question is that mention the construction difference between forward curve and backward curve fan.
Forward curve is it's a construction wise, if you see, there are multiple blades and it is made up of GI, whereas backward curve fan impeller is made up of MS. So backward curve is always having the more static carrying capacity basically, and forward curve is having lesser static carrying capacity. So that is the major difference between the forward curve and the backward curve.
Okay. Is anything curious? Okay, Jiget ji, have you got your answer?
No, sir.
Please ask whatever you want to.
Can I ask you directly?
Yes.
Yeah.
Sir, actually, I just wanted to know why it is termed as a backward curve or forward curve. Because if you have any figure, it would be very easy for us to visualize how it is curved.
Backward curve, as I told, it is for the high static, like static pressure.
That is your application point of view. I'm asking from the construction point of view.
Construction point of view, sir. See, as I understood your question, like if you are talking about in the size, or you are talking about how it is. Can you repeat your question?
Yes, मैं ये पूछना चाहता हूँ, ये जो ब्लेड वेन्स होती है वो कर्व होती है, तो उसको बैकवर्ड कैसे कर्व करते हैं और फॉरवर्ड कैसे कर्व करते हैं?
Sir, it's a complete machining part. Okay, so backward curve, it is comes with the in between the inlet cone, both side inlet cone will be there, and in between plate will be there, MS plate will be there, which will be welded between the two cones. So that is the basic construction of the backward curve fan. And backward curve, it is always wider into the width. So it comes with the two kind of construction. One is SISW, single inlet, single width, and other will comes with the DIDW, double inlet, double width. So as per your application, when suppose you are going for the kitchen ventilation, then preferably we have to go with the SISW fan, where we have to make the construction in such a manner that motor has to be outside airflow path, and width wise this fan will be lesser and height wise it will be more. When we will go for the DIDW backward curve, SISW and DIDW both is available with backward curve. So in that case, both sides suction will be there, and it will be wider into the width, and it will be lesser in the height. So that is the construction difference basically.
As a layman, I'm asking you, how do I come to know? Suppose मेरे सामने दो फैन पड़े हैं, कैसे पहचानूंगा कि ये फॉरवर्ड कर्व है और ये बैकवर्ड कर्व?
Sir, I will show the basically photograph over there. So this you can see the blade construction, sir. This is backward curve blade. Okay.
So ये rotation की direction से उल्टी direction में curved होती है. You mean to say that, right?
Sir, उन दोनों के बीच में जो प्लेट के बीच में जो डिफरेंस है ना, that will be little bit more than the forward curve. This is the forward curve. You can see the difference. You see the blades are very close to each other.
Curve तो same direction में होगा.
It is available with the both the direction, for counterclockwise and clockwise. But here what you are seeing, this is the clockwise right now, and it is the you can see it is blade is somewhere, it is in the backward direction, sir. You can see.
ये backward direction वाला पता चल रहा है, लेकिन forward. So you mean to say कि जो backward direction वाला जो fan है, उसको मैं forward direction में घुमाऊंगा तो वो क्या करेगा फिर? Reverse suction करेगा?
Reverse suction करेगा, yes sir. That's why when we are taking for the approval, going for the approval, always we are confirming from the client it is counterclockwise or clockwise.
तो ये अगर जब इसका प्रोटेक्शन भी टेक केयर करना पड़ेगा कि रिवर्स डायरेक्शन में ये ना घूमे.
Yes sir. So whenever we are taking the GAD approval, we are always confirming from the system, from the contractor, ki what exactly direction you are required, like their duct rotation is some other side, so we have to go with the counterclockwise. So that is complete depend upon the duct routing, how your duct routing is going on.
बेसिक नॉलेज है, वी आर डूइंग ऑडिट, लेकिन हमें बेसिक चीजें पता नहीं होती. फॉर एग्जांपल किसी भी एप्लीकेशन में हम लोग गए तो हमने प्रेशर मेजर किया और वॉल्यूम तो देख लेते हैं कैसे मेजरमेंट पॉसिबल है कि नहीं, तो उस तरीके से हम लोग एफिशिएंसी निकालते हैं. लेकिन ये पंप की ये फैन की सुटेबिलिटी है कि नहीं पर्टिकुलर एप्लीकेशन के लिए, वो नहीं बता पाते, बिकॉज वी डोंट नो. हमें कैसे आइडेंटिफाई करना है कि एप्लीकेशन के लिए, पर्टिकुलर वॉल्यूम के लिए, पर्टिकुलर प्रेशर के लिए ये सुटेबल है, या इससे चेंज करके कोई हायर एफिशिएंसी फैन भी मिल सकता है. सो ये हमारे प्रैक्टिकल इश्यूज है. और सेकंड थिंग, हमें ये भी पता नहीं होता कि प्रेशर कैलकुलेट, क्योंकि एज एन एनर्जी डोमेन में बहुत सारे डिफरेंट स्ट्रीम्स के इंजीनियर्स होते हैं. फॉर एग्जांपल आई माई सेल्फ फ्रॉम इलेक्ट्रिकल बैकग्राउंड, हमने फैंस पढ़े हुए हैं लेकिन इतने ज्यादा हमें नहीं पढ़ा हुआ. तो ये प्रेशर कैलकुलेशन कैसे होता है, फ्लो तो चलो मिल जाता है, लेकिन प्रेशर कैलकुलेशन, सपोज ये सिस्टम मैंने बनाया, थोड़ा डक्टिंग का डिजाइन थोड़ा पता चल गया कि इतना डक्टिंग होगा, इतना साइज का डक्टिंग होता, तो ये प्रेशर कैलकुलेशन होता कैसे, और ये सब कुछ चीज सपोज ये सबको हमें रिफर करना हो तो कोई बताइए, हैंडबुक है या कुछ भी है, सो दैट वी कैन कम टू.
Yeah, basically there is first for the backward curve and forward curve, I will tell very frankly ki whenever your static pressure is more than 50 mm, directly we have to go with the backward curve as well as for the aerofoil curve.
50 mm तो बहुत कम प्रेशर होता है.
Yeah.
हम लोग तो इंडस्ट्रीज में प्रेशर का डिफरेंस तो बहुत ज्यादा हमारा. हमने सपोज मैं एक बात करूँ, अभी एक एप्लीकेशन के लिए मैंने काम किया था, तो वो SO2 ब्लोअर था सर. तो वो सल्फर डाइऑक्साइड गैस को ब्लो करके आगे बहुत सारे इम्पीडेंस थे, प्रेशर के ड्रॉप होते थे, बेड्स होते थे जिसमें एब्जॉर्ब होता था और हाइड्रोक्लोरिक एसिड में कन्वर्ट होता था. तो वहां पे तो प्रेशर ड्रॉप बहुत ज्यादा होता है. और वहां पे उन्होंने जो है ना, जिसको क्या बोलते हैं, जो एक्चुअली बोल नहीं सकते कि वो फैन ही था. ये फैन और कंप्रेसर का जिसका स्पेसिफिक रेशियो जो है ना, वो फैन से ज्यादा होता है और कंप्रेसर से थोड़ा कम होता है, वो रेंज में उन्होंने डिजाइन किया था.
Just as whenever your static is increasing to higher side, sir, always try to select for the aerofoil curve or backward curve fan, sir. So that is things we have to keep into the mind. So whenever your static is increasing, always preferably we should go with the backward curve fan, which is having more static carrying capacity, sir.
कोई लिटरेचर बताइए सर जिसको रिफर कर सकते हैं और हमारे मींस के हमारे सेल्फ को एलिवेट कर सकते हैं, क्योंकि ये अभी एनर्जी में लो हैंगिंग फ्रूट्स वाली बात चली गई। अभी तो प्रोसेस रिलेटेड बहुत सारे प्रॉब्लम्स होते हैं जिसको कैसे आइडेंटिफाई किया जाए। अभी फैन को तो पता नहीं चलता मत फैन होता है। काफी अभी बड़ी इंडस्ट्रीज में तो उनके पास कुछ डेटा, डिजाइन डेटा भी मिल जाता है, लेकिन कुछ जगह पे तो जहाँ पे मीडियम स्केल इंडस्ट्रीज है वहां पे तो डेटा भी नहीं होता सर, और कंडीशन भी इतनी पुअर होती है तो हम कुछ पता नहीं कर पाते कि कौन से टाइप का फैन है।
I will share the product catalog, sir, afterwards. So there are all the Kruger products are available there. So I can help in that manner that if I'll share my contact number also. So there is no such. I'll also check some books are available in the market so that I can refer that for the selecting the fan for backward curve and forward curve or axial fan or centrifugal fan. So in that manner, if any books are available, otherwise I will share my product range catalog to you. So there are all kind of product with the nearby static pressure CFM ka some details are available over there. So you can refer that product catalog. So you can and after that you can check once with us. So we can guide you in that manner, sir.
Okay, sir.
Okay. Another question from Vivek ji. Can we use backward curve fan for dust collection application?
Yes, we can use dust collecting application, but always we have to also see the what is the dust particle size also. So on that basis also we are having different kind of fan. So that can be utilized for the for such application. Yeah.
Is there any queries? Okay. Thank you, Tarunji. It was a really grateful session with you.
So just I will take 10 minutes maximum. So
Yeah,
which is part of this slide and which is very important for when we are going for the selecting the fan. Fan selection is done, but the major part is the installation. So where mainly people are making the mistake, and I will maybe I will take 10 minutes maximum for just to make the system effect. What is happening actually for installation kind of thing, that is also very crucial to make your system more effective, more in power saving, energy saving, when you are using the right fan direction with the right orientation. So I'm running shortage of time, so I will just quick skip some. This one I will directly go to the pictorial representation. As per AMCA, actually, basically to avoid the system effect, they have told that minimum 2.5 duct diameter should be there. Straight duct, I'm talking about straight duct, should be there at outlet, and minimum 3 to 5 times of the fan size duct diameter should be there at inlet to avoid any inlet or outlet swirl actually. So actually you can see the recommended photograph and not recommended. You can see here they have used at inlet immediately bend they have used, which we have to avoid for the like to turbulence the flow. We have to always use the straight duct over there. If you are having any like constraint, like you can't put the straight duct, you should always use some splitter kind of arrangement so that your air should be guided properly and you will get the proper whatever fan is designed for. Suppose some CFM is static, these all CFM and static loss will be there at maximum bends also. So we should try to avoid the maximum bend. Again, you can see here if branches are there, always we have to put some splitter kind of arrangement so that air will be guided properly and your system will be more effective. Further to that, in axial fan, it is always recommended to go from the impeller to motor side. So you will have the proper cooling for the motor also, and it will be proper casing will be available for the air will travel for the longer distance, and flow will be flow will be very in efficient manner, and noise also will be lesser. And try to avoid the direct any obstruction after the axial fan. At the same time, suppose if you are having any top discharge, so you should not keep the space open, because you can see the back pressure will be generated and your power loss will be more. So we have to give some kind of duct arrangement at top, so that flow will be in a right direction. There will be no back pressure will be generated with the same air. At the same time, when you are having any duct sizing, so you see the not recommended for the first photograph, which is immediately they have taken bend at upside. Rather than that, you would have taken 270-degree orientation of the fan, and your flow will be straight, and you can have the better performance from the fan. At the same time, when you are putting the duct, try to avoid the oversized ducting. Try to put the same size of ducting, so that you can see the air is air turbulence is there. Some of the air is going back, so it will again create a back pressure in the system. Further to that, if you are having such kind of arrangement, so you can see here, rather than going for 90-degree fan, you can directly go with the top discharge fan, and your at least two bends are avoided immediately. So right orientation of the fan selection also is a very important while you are making for the making the installation over there. As I told that we have to take the axial fan from the impeller to motor side, when you are having the better efficiency for the fan and in the lesser size. When you are having some branches over there, then you can see three kind of installation photograph we have put it. One is poor, fair, and good. So here what they have did it, they have made the plenum over here, and they have taken a branch, and that all bends they have created. So here the things is they would have done with the branches, and then they would have put up the plenum. So your flow, you will have the better performance when you are putting 2 or 3 fans in a single plenum. So, and here you see the poor outlet, some photograph we have put it. Whenever you are putting the fan, they are always in duct and fan, it should be always flexible connection should be there, and duct should be straight as well for the certain distance. When you are you can see the photograph over here. This photograph clearly shows that there is the direct back pressure is generating over the fan. They would have taken that fan little bit outside, and they would have taken this kind of arrangement, which will avoid the bend and as well as the back pressure over the fan. When again you can see the example of the branches. When 2 fan you are combining in a single duct, then again you have to go with some flexible connection, as well as with the when you are putting the common duct plenum, then you have to go for some certain distance for the straight duct, then you have to go for the branches. You can see here there is the top discharge, and they have put it the obstruct above the fan. So what they would have did it, they would have taken the certain length of the duct, straight duct. After that, they can bend it. They can put the bend, so to get the better performance. What will be happening here, the back pressure will be generated in the system, your power consumption will become higher side, and over the period of time there is a high chance that bearing will get failed. At the same time, you can see this example also. We would have gone with the some length of the duct, straight duct. After that, we would have gone for the some bend rather than going with the immediate bend over the fan. Here you can see the installation. Typically, there is 3 kind of better installation has been shown in the photograph. It's either they would have gone with the top discharge directly rather than going with the 90-degree to avoid the pressure loss within the fan. Then further to that, you can see this again. They had taken the 90-degree fan orientation rather than taking the 90-degree fan orientation. They would have gone with the 270-degree fan orientation, and your immediate this 2-3 bends had been avoided, and your power consumption become the lesser than this system. So you can see the other photograph also. Here they were taken wrong. They would have taken here it was 270-degree rather than taking 270-degree. They have taken 90-degree, At the same moment here they have taken 270° and rather than taking 90°. So we have to always be careful that we should minimize the bend and any kind of immediate bend. So such kind of arrangement can be just, we can think like what best orientation fan can be taken so to make our system more comfortable, more superior than the existing one. You can see here also it can be taken with the top discharge, and your 1, 2, 3 bends has been immediately been avoided, and your pressure loss been reduced drastically. So again, further photograph, you can see it been taken the down blast kind of arrangement, and your one bend is avoided immediately. So which is again, these all kind of installation, what my main purpose was to show that if you select the right fan with the right orientation, you can avoid the pressure loss. Your fan will become more efficient with the lesser power consumption. Then again, see the branching kind of arrangement, that is in single plenum it is not recommended. You have to give with the different branches for if you are using the 2 or 3 more than 2 fan in a single duct plenum. So this is again poor inlet. If you are having such kind of arrangement, try to avoid it. Go for the straight duct to make your system more efficient. Here, one more example, I just want to show that whenever you are putting the straight duct over the fan, try to give some different support for the duct. So that will avoid the, whenever the fan manufacturer are selecting the isolator for the fan, in that case, they are calculating weight only for the fan, not for the duct. In that case, what will be happen? All your complete duct load will come on the fan, and proper isolation will not be happen. And in that case, your bearing will get failed immediately. At the same time, when we are going for the axial fan, we should go with the such kind of arrangement where your duct is always straight. So, and here is the orientation details which is available with the Kruger and almost with all the manufacturers. So try to take the right orientation for your fan to get the maximum efficiency from your fan. So that's all from my side in the system effect. Thank you so much. That's all from my side. If any further query in system effect, we can answer that.
Thank you, sir. Yeah. So we closing now.
Okay, sure. Yeah, thank you, sir. Thank you for giving me such a beautiful opportunity, and it's a